And we're live. Welcome back, everybody. My name is Ted, and you are watching the unofficial Mac OS platform layer for Casey Muratori's Handmade Hero. We're currently at day number 8, and I always like to start this off just by kind of saying why we do this. And the obvious reason for me is we actually get down into the details, see what it really means to make a game. See, it's about moving around the furniture and sort of seeing what's underneath there and really understanding it. But I actually think it's a little bit deeper than that. I actually think that what we're trying to do is take back control in general, in our own lives and in the kinds of things that we do. And so I really look at this as one sort of exercise in that particular project. I kind of got started into it because I wanted to not really have to pay for an engine and not have to buy another computer. So I was basically being cheap. But in the process of doing that, I realized that I could end up making something much better. And this sort of lesson, I think, actually carries over to many other parts of your life. And you may not even realize it, but I'll just give you one example really quick. My fridge is like right over there. But what I have here is actually a, I know this seems totally silly, but I've got a loaf of bread. Okay, and I didn't buy this at the store. I actually baked it myself. It's surprisingly easy to do and much cheaper. You just go and buy the yeast online. It's frozen, and then you get a huge bag of flour, and you do the fermentation in your house. You don't even need any special equipment. You don't need, all you need is a friggin' oven. But I started taking it even further. So this is homemade yogurt, and it was kind of scary to me at first and it's totally drinkable, like actually pretty darn delicious, good stuff, and actually much cheaper than anything that you could buy at the store. And so where am I kind of going with this? Well, it turns out that both of those things I thought were actually much more difficult than they turned out to be. And for some reason, I had kind of been living my life sort of just kind of accepting the world around me as it was, not necessarily questioning things that are going on, not, shall we say, moving the furniture away and just seeing kind of what's underneath there. And what I learned is, by moving the furniture around, by actually making this kind of stuff myself, not only did I end up with something better, but I ended up spending a lot less money, and I end up, in some sense, taking control of my life a little bit more. So, and I can take the money that I saved, and I can go and I can invest that in something, and now it is earning me passive income, and that is pretty much the very definition of freedom, if I ever could think about it. So I would look at it. I would look at this kind of a thing that way. I actually think this idea goes beyond what we're doing here, writing a game from scratch. And it's not always valuable to do something from scratch. I fully submit that is true. There are many circumstances in life where my car broke down and I really don't understand what the hell is going on in there, and so it makes sense for me to get a mechanic. But I think the point is accepting the world around you as it is shouldn't be your default. That what you should do, I think, is try to question more of the things around you. When you have time, see what it's like to move the furniture out of the way and poke around and try things out, and you may end up discovering that you like what you see. You may end up being happier with the result if you take a little bit more control. I certainly have been. So I'm going to put my stuff away in the fridge. And we're going to get back to coding. So let's see, where do we leave off? On the end of yesterday, I've had a little bit more time to do this. We hooked up, we finished the game controller input. So as far as I'm concerned, Sony PlayStation 4, DualShock, or whatever controller is done. And now that sort of leaves open the question, well, what about the keyboard? So I've got this Mac Apple keyboard in front of me. And I'm kind of thinking, okay, well, what can we do here? So what we want to do is get input from the keyboard that is sort of similar to input from the game controller. And we want to be able to use that to control what happens on the screen. So there's some places where that is possible, where we can do that. And we actually already have code that looks at that part. So we've got this this event loop right here, right? So ns event star, and what we're doing is we're asking the application instance, which is kind of this is a part of actually part of the fundamental frameworks, or I think Cocoa framework. And what it's going to do is it's going to keep getting us events. So we're tying into the main event loop here, and we're going to look at the event type. And so there's a ton of different event types. We can actually look at this NS event in the documentation and see what that's all about. But there are several different event types. Two of them are key up and key down. And so this is actually tied right into the keyboard. So we have a way of hooking into what happens when a key gets pressed and when a key does not get pressed, or when a key when you lift your finger from the keyboard. So we have ways of doing this. And so let's go take a look. Sorry about that. That's just covering the entire screen. So I'm going to go and I'm going to look for NS event. Okay, and so Apple's documentation will come right up, and we can read this. So NS event. So the event type was what we were interested in. So we know that when we're going over this loop here, that gets run every single time in the app. We know that we're getting this this input. Actually, I think what we need to do is we need to move this up. So we're going to move this up before all of the other stuff, before the render gradient and all that other stuff. There were certain, I don't entirely know why, but there were circumstances where that was causing problems for me earlier. So I'm gonna do that. So what we're gonna do first. The first thing we do in this loop for the game loop is we're getting all these events, and we're going to see if there's anything that kind of matches key up and key down that we're interested in. So we're going to do that. And the type, the NS event type, and there's tons of these, that's kind of what we're interested in. So this is this giant enumeration value, and there's a bunch of these. So this actually ties into the mouse, so ties into those things. Ties into key down and key up, which is actually what we're interested in. There's a few other things that are that come from this NS application instance, and what we're interested in is key down, right? So key down. Now if we do something like, so we've got this kind of switch statement. I forget, I think it's like, I just do case NS event type key down. Okay. And I think all we want to do here is just do a log. So we'll just say NS log a key was pressed, right? And I think there's some detail that actually gets passed through this. So NS event type key up, and then we go, okay, log that a key finger was lifted from a key. I don't know. All right, so that's what's going on here. And first of all, we'll just see if we can build that. So we'll build it. All right. So that builds. So the compiler definitely understands that. And what we've got is, so I need to go back into my, sorry about this and this annoying thing. I'm running multiple versions of Xcode. I've got 10 on here. And that's right. Shoot. Okay, what I actually needed to do was go in here and open this up and go to day 8 and go to my Xcode directory. All right, there we go. All right, so that, oh, that's cool. That automatically gets rid of my screen there. All right, and so what we need to do again, I know it's kind of a pain, but every time I move that directory, since the paths are absolute, I just need to go back and I should fix that at some point. Well, I'm not really sure. It's a minor annoyance, but I just need to pick the day 8 executable. So I've got the day 8 executable, and what I'm wanting to do now is I'm going to remove all these breakpoints. So what we're interested in is kind of seeing, okay, what do these ever get hit, right? So if I run it, do I ever hit those events? So now the app is running. You can see that it's in the foreground. Oops. Did not want that. I wanted to hit the D key. Okay, and so you see we have a problem here. The problem, it seems, is that we're actually not able to, for some reason we can't seem to get this window to take our keyboard input. If that makes sense? It seems like for some reason like the window just it's like not passing through or anything. So this is strange. Right, so this is actually the problem that I ran into not too long ago when I first did this. So I was thinking to myself, okay, so this is very strange that I just, no matter what. So I've got this code in here that supposedly handles pressing down a key, but it doesn't seem to register, you know, doesn't like so I think if the window itself could actually respond to the key press, then this condition would probably get triggered. But the problem is it's really not, it's actually not doing anything with the key press, or it's not able to sort of take input from the keyboard. And this is some pretty sort of platform specific stuff, and it's really something that I kind of discovered in the process of working on this. It was sort of like kind of an experimental thing that I even ran into it or figured it was a problem. But what it comes down to is the operating system really hasn't fully noticed that this application is this is an application that can take keyboard input through sort of the standard channels through this NS application kind of style way of doing things. And so what that means is we actually need to make what's called a bundle. And so you've probably seen, you've probably heard of this concept of an app bundle before. It's really nothing special. So pretty much every application in your system, so if I go into my applications, and let's just say that I'm interested in, I don't know, I've got Jonathan Blow's braid here. So let's say I want to just show package content. So that actually is a bundle. So when this application was delivered to the Mac App Store, it was delivered as a bundle, which is basically just a folder. So all I have to do is like right click on the thing, show package contents, and then I get this contents, and this has all of the stuff that's used in here. So I can actually inspect this thing, and I know that, okay, so we've got some like OpenGL kind of stuff going on here. So there's a few kind of dynamic libraries that are in here. and I don't know what some of these are, but there's a big, there's like a Unix executable in there. So you can actually kind of see what got sort of sent to the App Store. And then there's also this info.plist, which is just a file that is kind of like an XML that gives us some information about this particular executable. So it tells you the name of the thing that's going to launch in the system, the version, anything, categories, that kind of stuff. And so a lot of this stuff is pretty basic, not really interesting. What it is though is it's just stuff for the operating system to kind of understand that, hey, this is like an official kind of app on the system, and you just we're gonna run it kind of like as its own sort of app container. And that's sort of like one of the different kind of Mac OS philosophical. It's a bit of a philosophical difference with how Mac OS works. So, and I've actually noticed this building the platform layer. Very frequently, there are circumstances where, if I try and like load, say, a bitmap file outside of my application's bundle directory, outside of this folder structure here, trying to advance a pointer to data in that file usually results in a crash. And so usually what you want is you have all these resources, and the resources end up getting kind of loaded into here. And so in this case, it looks like they have a data folder. I'm guessing that these are art files of some kind. So they've packaged their own art. I'm almost certain that this is some huge compressed file that contains all of the art assets from Braid, right? And so then there's all these strings here, and these are your different translations of the game. So so you can offer it in all these different languages, etc. We packaged some fonts in here because that's kind of so all that stuff, that all the resources on Mac OS for applications go in this kind of bundle directory structure, and pretty much everything in your application is going to, all of those resources are not loaded from outside of your application folder. They're actually loaded from inside of this bundle. Otherwise, you crash. You have all these problems that I was sort of running into, building the platform layer. So it's not quite like Windows. And so there's two reasons why you want to do a bundle, but one of them is sort of to be like officially recognized as like a thing, like an app that's running on the system. That's about as colloquially as I can put it. But it is also so that if you load resources that your game depends on, like artwork, font, strings, that kind of thing, the operating system doesn't just kill you because you tried to like access some pointer that you got from some data that you loaded out of that. So these are things that we, so it becomes sort of eminently important that we put everything into a bundle of some kind. So I think that's important. We're going to do that. And all that, there's actually nothing that's all too special about that, really. So to do that, what we're going to do is we're going to open up our build folder here, or rather our build script. So we've got this shell script that does the build. And what it does here is, first of all, it just makes the executable, right? And so we've got this handmade executable, right? And what I think we could do is, I think we could just make the, so let's see, so we make this build directory first, and then we push we push a navigation into that build directory, right? That's what push D does. So we're in this build directory, and at the very end we pop that. So we go back to the platform layer directory that contains this build script in it. But all we're doing is we're just making this executable. That's the only thing that we're doing in this directory. So kind of later on, you can imagine, I'll just pull up sort of like a more advanced version of the platform layer that I have from, say, if I were to go into like day 37, I've got my shell script there. You can see that there's just a heck of a lot more going on here, but the core of it is really the same. So the core of it is we go to this build directory, we're going to build some stuff, and then what we're going to do is we're going to move some things, and then we're going to get out of there. Okay, so actually all that we're doing, and I'm just going to copy this. This is important. So what we're going to do is, oh yeah, well actually both of these are important. We're going to go back here. All right, so this is just, so all of these are just command line commands. So in Unix, rm-rf, handmade.app. So what we're going to, and we're actually just going to do this make directory handmade.app. All right, and so first thing we're going to do is we're going to remove handmade.app if it exists already. So we're just going to clear out what we had. And then we're going to make this directory. I believe the -rf flags on RM, it is like, I think -r means recursive, so it means recursively delete all of the other sort of subfolders. And F, I think that has to do with folders too. So that might mean like include folders. Go look it up. So that just like RMRF, just if you've used it before, it just means wholesale delete like all the stuff. Like don't just like delete kind of what like one thing, like delete the folder and all of its subdirectories. I think in Windows it's like del tree or something like that. So anyway, so then we're going to make this folder, and then what we're going to do is this is the executable. So what I think we need to do is we need to just do we just need to do CP. So CP just means copy, and we're going to copy handmade to handmade.app/handmade, right? And I want to see, I think that's what I do. Yeah, so CP, yeah, so this is that same command. So all I'm doing is I'm copying our executable from the directory in which we built it to the application bundle directory, right? So let's do that. Okay, and let's go take a look. So, oh God, sorry. I'm still getting better at navigating through all this stuff, but anyway. All right, so here's our build directory, and now what you'll see is we've got this handmade.app directory, okay? And so that actually is an executable. I can even look in here too. Why don't I do that? Just so you can see that it looks quite a bit different from, say, something that you've seen elsewhere. So if I'm looking at this one right here, if I go to my build directory, you see that this now looks like a proper application, right? So the operating system, Mac OS, knows, it just knows that something, if a directory is called .app, then it means like interpret that whatever's in there as an application or as application content of some kind. And I can show package contents, and there you see our executable. So we know that is kind of that's the executable. Now if we kind of go back here and we try and launch the thing, okay, so we can launch it. What I don't know is kind of if this will take my key presses. Maybe it will. Do you hear that noise? So there's this noise of kind of saying like, you know, hey, this application doesn't really know what to do with a key press. But this is actually great. So what we've already done, just by virtue of just through a little bit of experimentation, we've made a bundle for the application. There's a little bit of extra setup that we have to do, but it's pretty cool that just double clicking on this, you know, we're no longer, this is different from, say, like launching in the terminal, which is what this one does. So if I just, you know, launch the straight up Unix executable, then I get this extra terminal window, and then I close it, and then the terminal window kind of says some stuff. this is sort of more in tune with a customer kind of facing thing. So if I just double click this, it's more like an app as the sort of lay person would understand, right? So that's pretty cool. So we got that, but there's still this matter of, and another thing too that we might be interested in seeing is whether this thing will actually swallow our key presses. So I'm just kind of going through in this, like I said, I've already done a lot of this stuff, so I'm kind of being empirically minded. If we were, if we knew nothing about any of this, how might we approach it, right? How might we approach it sort of with a scientific mindset? One of the first things I would kind of think of doing is clicking on this this bundle here, and then saying, okay, I'm going to choose that, and I'm going to close it. And then what I'm going to do is I'm going to, so I've still got my breakpoints in there. All I've done is I've changed my executable, and maybe what I would want to do is I want to put like a breakpoint in here, first of all, just to see that the debugger even notices my executable, right? So that's going to be pretty important. So we're going to want that. Okay, so that's a problem. Oh no, that's actually not a problem. Never mind. So we hit our breakpoint, right? So that's good. So now we know that we can debug the bundle as an executable. So that's pretty cool. So we're gonna keep running. And now what I'm kind of curious about is like what happens when I press this. Okay, we still seem to have this problem of, yeah, so we still have this problem of the window not taking key presses kind of while it's being, so that didn't really solve our problem, did it? But we're a little bit closer to solving the problem. So I say we push on. So that's kind of how this works. So we have that. But another really important part of any kind of application sort of being officially recognized by the operating system is that it have an info plist. And so what we're going to do is we're just going to make an info. We're actually just going to kind of copy an info plist. So I've got one, and what I'm going to do is I'm just going to go in and see what did I do earlier. I think I did. Okay, so handmade resources path. So /handmade/resources. So I like to just kind of, how you do this is sort of up to you, but I like to just make a little like resources folder here. So this is our resources folder. And then what it's going to contain is just kind of a boilerplate template info plist. Now there's a lot of ways that you can make one of these things. If you just like create an Xcode project just from here. So if I go to File, New, and I make an Xcode project, if it's just like a single application for the Mac, then you'll just get an info plist kind of by default in there. I've had one that I've been using for my platform layer. It's nothing really special. I got it. It's just modified from an original kind of info plist that came out of a default project from Xcode. So that's sort of what I did with that one. So I'm gonna go back here. Actually, I'm interested in this. I'm gonna go to resources. I'm just gonna paste it, and let's poke around in there and just sort of see what's going on. So I'm gonna, let's see. Oh no, that's not where I want to be. All right, this gets confusing pretty quickly. All right, so I'm going to my resources directory, and I'm gonna look at this info plist. And so all this does is it just contains some really basic things. So we've got, bundle name, kind of package, short version, versions, copyrights. This is probably not me, should be somebody else. I don't know. It's not important, but copyright none. This is open source. I don't know. All right, so, and then NS principal, this NS principal class, I believe, NS application, this is how the system recognizes the window. So I actually think this is pretty important to have in there. So now we've got, just to be clear, we've got this info plist in the resources directory, but it's not actually, if we run our build script, it's not actually compiled into the bundle. And so part of what our build script, well, not compiled is not the right word. It's not copied into the bundle, right? So we've got the source code, which is compiled, and then the executable is copied into the bundle, right? But then we've also got this info plist that needs to go into the bundle. That's not really compiled. It's just a boring old text file that we just have to have. So we're going to do, I think I have the line to do that. Yeah, right here. And I think for some reason I decided it was wise to have this resources path. Yeah. I don't know. I actually just think I'm more inclined to not do the full thing yet because I sort of feel like it gets confusing. So what I would rather do, so we have this handmade resources path, but I think what I prefer to do is just do the full path from the other file. And part of that is this kind of idea of, it's about not doing abstractions before you need to. So the idea is there's wait, really? I put that in the code? I didn't put that in the code directory. Oh shoot, that's wrong. Whoops. Okay, so I actually want this one. All right, sorry for the confusion. All right. Okay, so kind of back to the main thread there. The idea is, yeah, later on I end up reusing this resources path. I certainly do. And there's really, I guess there's no reason why I couldn't go and put it up here in a variable. But I'm not reusing it yet. And I don't want to kind of send the signal to other people that may be working on this, that this is the sort of thing that I intend to reuse until I start to reuse it. And so it's sort of this idea, Casey calls it compression-oriented programming. I kind of like that term. But it's really, what it comes down to is just a pragmatic thing. It comes down to don't compress something, or don't make something kind of big and hairy and abstract, or don't make a variable out of it. Don't make something reusable until it actually needs to be reused somewhere else. And the idea is we're trying to lean towards a preference for clear, understandable, direct, straightforward code. And later on, we may find that we need to change this to reuse some parts because that's going to result in less duplication. But if it's possible to get away with clarity, if something isn't really reused, we shouldn't write it that way. I know I'm making kind of a big value judgment, but what I found is that this eminently leads me to being able to actually understand a project that I'm on. So I prefer to just have plain strings in here. I prefer to just be able to read sort of this path and just know exactly where that is, instead of having to look up in some other file. Maybe I'll be lucky if it's at the top of this file. It might be in some other file somewhere else. So all I'm saying is, if it's possible to not have to do all this navigation to another file just to figure out where I am, I think that's a win. And later on, if we have to avoid duplication, if we have to move this, then we will do that. And we certainly do that eventually. But anything other than just pasting a blank string in here right now, in my mind, is what I would call like premature design. It's sort of putting the cart before the horse. It's pretending that you know what the future is going to be before that time when you need that thing has actually happened. All right, so long rant aside, what I'm going to do is I'm going to build this now. Okay, and so now that is, so now what we ought to see inside of this, we ought to see our info plist. That's pretty cool. So now we have something that looks more like a proper bundle, okay? And kind of what I'm interested in now is this thing going to stop yelling at me if I... Okay, so there we go. So interesting. So, and I know that this is, shall we say, not the most satisfying kind of programming, right? And I say that it's not satisfying because what we're doing is like I don't know why, like there's no documentation, right? So if I go to Apple's website and I root around, there's no documentation telling me, oh, by the way, Ted, an application is not properly going to recognize key presses unless you make this thing called a bundle, and then you copy your executable into the bundle, and then you also copy this info plist into the bundle. Like there's nothing saying that, at least to my knowledge, right? So I literally discovered this through experimentation and through just sort of like silly persistence, really. It was just like, okay, well, if I make a default application from the default template and I look at that and that thing seems to take my key presses, okay, well, why does that take my key presses? Well, it's got this info plist and this other thing doesn't have this info plist. So by a process of deduction, I figured out that, I need an info plist, or, well, not necessarily figured out, but I figured out that I needed to try putting an info plist in there and just see what that does. And so it's, like I said, it's not satisfying because usually when I make things, I like to kind of like know, at least have some concept in my head as to what I think I need to do before I do it. But in this case, that's really not going on here. Like, it really is just like, yeah, this is how the thing works, and like it's not documented, and you're just going to have to figure that out. And so, and in a lot of ways, like we're kind of operating sort of outside the boundaries of how a typical application on an Apple platform is made. And so we're sort of, we're sort of breaking ground that not a lot of people usually would. Most people would make this application. They'd have, we'd have an application delegate, and then that thing would take the application did finish launching, and then we would, we'd have all these like official sort of like object-oriented paths that we would go through. But I think, part of this goal, again, the goal of this is to move the furniture aside and actually understand what's going on, or try to understand what's going on. And that means breaking some of our assumptions, or rather breaking the standard way that an application would be made, not just relying on UI application main or NS application main to sort of do all this setup for us, but to do the setup ourselves and really peel away the furniture and understand what's going on here. So that said, we have hit our debug breakpoint, so we know that a key was pressed. That's excellent. And so now, what can we get from this NS event star here that might tell us some interesting things about our key? So we've got the type. So the type here, modifier flags. I want to say that there's some actual like interesting stuff going on that's in there. I actually want to say it contains the key press value in there. So, I don't know, I'm going to try and print this out. Flags, time, context. Is it key code? Okay. So this key code here, see what I thought is that we had the like key code PO, let's print out event.keycode. Let's see what we get. 2. Okay. Actually, I think I want the hex for that, but I can't figure out a way to get to that. So I pressed the D key, by the way. So yeah, this is kind of what's difficult about inspecting some of these variables is they, yeah, I'm not really sure how to print this out as a. I could be totally wrong doing this, but let's maybe see if we can do a UN32. No, okay, that doesn't change anything. I actually have the keys that we're interested in sort of known here, but and maybe another thing we could do is actually just do a debug variable. Anyway, we're hitting the breakpoints, and then we also should hit this other one that you know that happens when you lift the key up. So we got that, and this is just going to get hit a ton of times. Okay, so that is good. So we're actually paying attention, or we're getting key presses, and this sort of lens. By the way, let's look at NS event here. So key down. All right. Event type. Yeah. So I think NS event has this. Okay, that's the event type. NS event has this key code thing in there, and we're interested in that. Okay, characters, key code. Okay, so that's a unsigned integer 16. All right. Unit 16, key code. All right, so why don't we just like see what happens if we put the variable? What I'm kind of curious. Again, I'm trying to do this sort of empirically here. So what I'm trying to do is say, okay, UN16 key code equals event dot key code. And what I'm hoping is that we can then inspect this variable. Yeah, actually, we don't need that. Yeah. Okay, so that's the key code. Oh no. Okay, so we're gonna edit. Sorry, this is the problem of having Vim as your editor and then also having separate editor. So key code, and then that's going to be event.keycode. All right, I'm gonna write that, and we're gonna build. So build. Cannot jump. Oh, oops. Is that? That's not what I wanted. All right, so we actually wanted this here, right? Okay. We can agree that that was stupid. All right. All right, okay. So we got this, and we're going to quit the program. And what I'm interested in now is when I do these breakpoints, I want to see kind of what my key code looks like here. So I'm going to run this. And what I'm hoping is that we'll get some... Really? Key code. I was hoping not to have a... Oh, shit, okay, because sometimes the event can be nil. Okay. All right, I guess we got to be safer about this. All right, so we're going to be safer, and we're just going to do it here. And I know this is not important code, by the way. It's just kind of test code. So, what? I swear, you just want to do one thing. I did not want to read it. I did not want to do that. All right, you know what? I don't care about the other case. I just want this case. Jesus. All right. Is this going to shut up now? All right, no. Cannot jump from a switch statement to this case label. What? I don't understand what's going on here. Okay. Jump bypasses variable initialization. Cannot jump from a switch statement to this case label. Okay. I'm still kind of confused here. I don't know. Maybe we just need to like. I'm really. I don't know why this is not kosher. All right. All right, that built. Okay, fine. So we can't. For some reason we can't just initialize a variable. And okay, so we got that. There we go. All right, so now I'm gonna press the D key, and what I'm interested in is this key code. So what I'm hoping is that that's gonna show. Okay, so that shows as UN16. What's cool is we can do that as hex. Okay, interesting. So now that's now we know that's OX02, and we can then use that as a way of checking against the D key. So now we know what that is. And we can kind of keep going through. We're basically doing the same kind of thing that we were doing with so now I'm going to press the I'm going to press the up key, for example. I got to have this and my window needs to be in front. Okay. Okay, so now I just pressed up. Okay. And so I've got this up key, right? And the key code. So now we know what this key code is, and we know that up is 7E, okay? And so this is actually pretty useful. And what I want to do is just kind of confirm, from other bits of so got that. Not super interested in that. I'm gonna look at my my other platform layers that I've done. I'm pretty sure that we've actually got key codes. I just hard coded these, but I want to make sure. This is like 7E. Yeah. Okay. Cool. So 455. So right here you can see that and D was actually OX02. Okay. So this is actually great. So this kind of empirical way of looking at and figuring out what the keys are just by putting breakpoints in. You could go look this up, and that's fine. But part of what's cool about doing things this way is like we don't actually need an internet connection. We don't need any of that stuff. We can actually just understand how the system works without sort of any kind of external resources. So we know these things. I did like const, unsigned, short, or whatever, but you could just do these as unsigned integer, so that's fine. So we're going to get a few of those, and this sort of starts to beg the question of how do we actually want to map these controls, right? So what I'm thinking we do is, just since I don't really know, particularly what's going to be the best way of doing it, I'm kind of thinking we want to do just ASDF as the square, triangle, X, circle buttons, and then maybe just kind of go from there. So that's kind of my thinking on that. So what we should also do is just at the very top, just start having some of these uint16 values. So, it's not really a global variable, it's just const uint16. So, like D key code equals OX02, right? Const uint16. up key code. What is that? 70. Okay. So we're going to do that. And then we're going to do, so, yeah. We'll just do ASDF. Or we'll do up, down, right, left. Okay, so left arrow. Yeah. Unit 16. Left arrow key code. Yeah, we don't really need this either. I'm just doing the ones that we care about. And really just showing you how you'd be able to derive these values if you yourself didn't know what they were. We already have these, but if you didn't know what they are, you would just put breakpoints in and kind of do what I was doing earlier. So we're going to copy these. ASDF, sure. Maybe we care about Q, R, and L. Okay, so we care about all these other ones. And interesting. So this is actually, I'm going to use a Vim thing. It's kind of cool. If you're using Vim, you can do this kind of replace. So I do 44, comma 50 S, and I think that what that does is it searches, and then what we're going to do is we're going to look for unsigned short, and then we're going to replace that with UN16. Unsigned short. Really? Oh, wait. That's right. I actually think that spaces are allowed. Let's see. Yeah, so that just kind of does like a global sort of replace there. All right, and I'm going to make sure that I can actually build that and it doesn't yell at me. Okay, and that builds. So we've got all of these. These are just our key codes. You know, nothing fancy there. And then we can kind of go back down. And so you just kind of one sort of quick experiment that we can run is we can say, okay, well, so we're going to get rid of this because we don't need that. That's just kind of garbage code. And we can say if event.keycode equals up arrow key code, right? Then let's print something, right? Okay, so up key is pressed in that circumstance, and we ought to be able to just see that in the debugger, right? All right, so I'm going to go back here, and we're going to run through it. And let's just take a look. Okay, so this is in the foreground here. Okay, oops. Okay, yeah, so we get a bunch of stuff there, but you do see that we get this this up key pressed. So, oh god. So we get a lot of stuff. Oh, and then also this, a finger was lifted from the key. Okay, you know, that's just me being like super pedantic as always. I have a tendency to that. So I pressed the up key and we recorded that it was the up key. And just for reference, you know, I'm pressing like a bunch of other things and get nothing. Okay, so we know that we can detect up. Now we've sort of reached kind of an architectural decision-making point here, because okay, so we're in a good spot here. Really, we have a way to detect kind of what's coming from the keyboard. So we know when we press certain kinds of keys. We have a way of saying, okay, well this is left arrow, right arrow, down, up. We have all of those. All the keys, we're basically trying to map what's on this thing, you know, onto what's coming from this thing. And the kind of important point to make out here is we really have no idea at this stage of making a game or really any kind of a product how we even care about or intend to use the keyboard or the controls. And so what I really want to emphasize, and I think Casey does a really great job of emphasizing this as well, is this is just straight up not the time to be making any big architectural decisions. We don't know what kind of game it is. We don't know how it's going to handle input. We know nothing about this, actually. And so it isn't really worth asking questions like, oh, well, should the up, like, what happens if you're on the keyboard and then you switch to the game controller, and how should we handle the switch off between those, and how exactly should ASDF be mapped to square, triangle, X, and O, and what would that mean for the game? What about the analog stick? Like all of these questions about how we control the game that don't really make sense for a game that doesn't exist yet. And so this is just kind of a sort of a place to reflect on the fact that it's not a very good idea at this stage to try and predict how we're going to use the keyboard. All that we really care about is, can we take what's in the keyboard and map that to what's in this like Mac game controller struct, right? So what we care about is saying we kind of want sort of like a universal, well, not universal, but we want is sort of this concept of a game controller that makes sense on the Mac platform, like a Mac platform oriented kind of game controller. And we want that thing to map to, we want it to be this, we want that concept to be the same between the game controller, this PlayStation thing that we got here, or anything else that you plug in, really, and a keyboard. They're just kind of controller inputs. That's sort of what they are. And so what I kind of want to emphasize is that the mapping between the keyboard and the PlayStation controller doesn't have to be one-to-one for this to work, or for this to be okay for the purposes of prototyping, really. So if you think about it, what we're really trying to do is we're trying to say, okay, well, some key press on this keyboard right in front of me, some key press means, some key press means square button, right? And some key press means triangle button, right? And some key press means X button, circle, left shoulder, right shoulder. I don't necessarily care what those are right now. That's not important. What's important is that something is mapped to this struct, right? And so what we're going to do is go back into the main. Go back into main. And you know how we've set up, so we've got this struct that's like the Mac game controller, right? And we've got this setup game controller thing where we pass a pointer to it. We've also got this separate struct here that is itself a Mac game controller. And it is the keyboard controller, right? And that's just a blank struct, right? Okay. And it is more or less the same as the game controller, except it just, what we've got here are two controllers, effectively. Two controllers that can run the game. So you could decide that imagine that maybe just the first sort of iteration of the game, just for prototyping purposes, we would just imagine that we have a menu where we could switch from the keyboard to a controller to a game controller that's connected. That's all this is we're just saying, like, the two are totally separate, and we can just kind of pick one that we want to use as the input for the game, right? So, and what's cool about this now is all that I'm doing in this, when I know that my up arrow key was pressed, okay, that means something. But actually, I don't really want to do that right now. Because and the reason I don't want to do that is because up arrow and up arrow and down arrow and left arrow and right arrow have to map to the D-pad. So there's actually some more kind of specific logic in there about how that works. What I'm actually interested in here is let's look at let's say a key code, okay, and let's say that what I wanted to do was I wanted to map pressing the A key code. I wanted to map pressing A to, say, the X button, okay? So then what I would do is I'd say, okay, well, keyboard controller dot X button state is true, right? And so what that means is I've now been, now the X button is pressed. But that also means that we need to, on the reverse, handle a key up. So I would say that when it's the A key code, then this is false now, right? So what we're doing is, and we can get rid of this silly. We don't need this anymore because whatever. We know that this code's getting called, so that's good. Now we've got these separate controllers, and then down here, well, we've got our we've got this. So we're using the Mac game controller here, but we could easily swap this out with something else. So what we could do up here before the game even gets running is, maybe like right here, we just do a note and I say, this is where we decide what input to take, right? So maybe what we want to decide is we want keyboard for now, right? So instead what we'll do is we'll just say, we'll make a Mac game controller struct, right? Actually, what we could do is we could just do a pointer to a game controller. We'll just do a star, and then we'll just say, because there's no need like initializing state or anything like that just for this, because all we want to do is point to one of these. So we could say this is just a pointer, and we just say, yeah, and actually, like, let's call this like more specifically. We could say that this is the PlayStation controller, right? And so then we're going to pass this in here, right? And then what we're going to do is we're going to say that this is, yeah, Mac game controller. And we'll just call this game controller, right? More generally. And that right now is going to be equal to the address of the keyboard controller, right? And so all we've done now is so now we're pointing to the keyboard controller. The keyboard controller is actually what's going to take our input, not the connected game controller. And I go down to my logic here. That's a lot of this stuff is going to work, and I have to change it as well because we're dealing with a pointer. We're not dealing with just a plain struct. So we're dealing with a address to a struct. I think this is right. So game controller. Still getting my, tell you what, when you're an iOS developer, you do not deal with pointers directly that much. So, okay. But then I also want to put in another one that's just like, if game controller X button state equals true, then increment the X offset. So we'll just do that. All right, so increment that. Let's see here, do we get any compile stuff going on here? Oh God, okay. Oh, oops. I did not mean, oh God, that's embarrassing. Okay, well, I actually meant to. Wow, that's such a rookie mistake. All right. All right. So now what I would sort of expect is when we press the A button, what that means is when I press the A key, then this game controller is actually thinks that it's got the X button pressed. So we've mapped it to the X button. And that's not working. Why is it not working? Okay. Nope. We've got breakpoints in there. Okay, so we hit that. Okay. Why did we not hit this? That's interesting. This is probably going to be something embarrassing, I'm sure. Gosh, I sort of would think that that would work. All right. Kind of what I'm curious is like, okay, does this work still if I have my, so irrespective of the keyboard, what if I just said I wanted the PlayStation controller instead? Does that still work? All right. Somebody can figure out how to keep Vim files in sync with one another. That would be excellent. All right. So we got that. All right. So now I'm just making sure that the PlayStation controller stuff still works and that we didn't break anything. Okay. Yeah, and that still works. Okay, so there's something up with this keyboard controller stuff that's going on here. All right, so that is interesting. All right, so we have confirmed that I still know how to use pointers, and but you kind of get the idea. Is we're setting this to the address of the PlayStation controller. So that. And so, but I think my concern here is like, I've got this keyboard controller, right? This keyboard controller struct. And yet, for some reason, the button state is not getting set or something. That's kind of confusing to me here. I'd have to like really, got game controller. I said it was X button state. Increase the. And we know that when we set a breakpoint there, that okay. So this is interesting to me because it's like we know that when we set this breakpoint, it's true. Okay, that's the keyboard controller. So I don't understand why down below we wouldn't have recognized the state. If we set this thing to keyboard controller, this is strange. All right. I'm just kind of thinking out loud about what we could do. controller, right? This is strange, right? I mean, it ought to like, okay, so I certainly get that, and the thing gets set. That's getting really annoying there. Problem is I don't want to, well, if I do a breakpoint, I got an idea. Okay, so what I'm kind of interested in is I'm going to I'm actually just going to comment that out, unsetting it. And what I'm going to do is I'm just going to set a breakpoint. And again, you know, you're seeing warts and all here. So as fun as that is, the idea is I'm going to I don't really know why this wouldn't get set properly. So the idea is my expectation is the first time if I set a breakpoint here, my expectation is that I ought to be able to inspect the game controller pointer here, this thing right here. So that thing ought to be the same as my keyboard controller, right? So that's all zeroed out. And X button state is yeah, so that's nothing. Okay. So that is what I would expect it to be, I think, for a default keyboard controller. And now I hit A, which means that this is going to get triggered. So I'm going to just be super cautious there. All right, so now we know that keyboard controller.x button state. Okay, so we know that is, oh, okay. Huh. All right, so we're scrolling, and we're scrolling because the reason that we're scrolling is because this has understood that the X button state is true, and so we put this here, right? And so we know that this offset is continuing to get incremented, right? So again, you know, the scientific method, observation, form a hypothesis, test your hypothesis, or just, you know, find interesting ways of kind of poking at reality and sort of seeing what it throws back at you. And this, you know, aside from, you know, you can go and you can spend all this time sort of like reading, you know, tutorials on like here's how to use this design pattern and here's how to blah blah blah, but like nothing will teach you this. This is sort of this is the skill. The skill is finding little ways to kind of poke at reality here. And so what we learned, which is sort of surprising to me, just given that I've already done this before, but what we've learned is this. If I have this on the key up and it gets unset immediately, I actually want to take a look at some of my other code. Maybe it's possible that what's going on is like maybe this case is like falling through or something, and then this would get set to false immediately. That actually seems more likely than not. I wonder if that's the case here. Gosh, that would suck. Let me see what I did in my other platform layer. Okay. Yeah, okay, yeah. Yeah. Okay, so yeah, this is not fun, but we need to do this. Oh, and I actually think we also need to like do this, which I hadn't done. on my other, like for some reason my other platform layer still works, and I never bothered to do that. Anyway, that's silly. All right, build this thing. All right. So now what I hope is that I've got it basically mapped to that same button, and kind of what I'm hoping is that pressing on A is going to scroll this puppy, and then as soon as I like let my finger off of A, it'll stop scrolling. So that's kind of the expectation I'm working under here. So we've got the window. All right, so when I'm pressing A, this thing is scrolling, and then when I left my finger off of A, it stopped scrolling. So I think we have a pretty solid kind of concept here of pressing a button down and then mapping it to the controller, which is actually really important. Sort of one kind of thing that I want to do before wrapping this particular session. As well, gosh, we're already at like an hour and 15 minutes. So I also just want to I want to get this thing to shut the F up, because it's really annoying me, and like every time it's like every time I press A button, it like just wants to yell at me. And this is actually something that I looked up earlier and was able to kind of get it working in my other platform layer. There's nothing really all that cool or interesting about this, other than this is a bit of Objective-C here. It's kind of an important, kind of some stuff to care about. So we did a little bit of Objective-C when we did handling the window closing, kind of because we had to in order to work with NS window, or in order to in order to be able to handle this window will close event. So NS window will send this close event to to an Objective-C delegate object that will take it will actually allow you to kind of handle this particular method, like have you run some custom code, have you run some custom Objective-C or C code when this window is about to close. And so that's kind of what we're doing here. We're just setting this running Boolean variable to false. But there's sort of other kind of system behaviors that we can tap into if we use some of this Objective-C stuff. So one of the things that we can do is we can get this to shut up by subclassing NS window. So we're going to make a subclass of NS window that's just the I don't know, I called it Handmade key ignoring window, but I just want to call it just key ignoring window. And so the idea is that, because right now what's going on is the game window is processing. So the application itself, the application object, is processing keyboard input, but the actual window itself is also processing keyboard input. And because we really haven't written any kind of custom code to tell the window what to do with that input, it is just considering the input invalid. So what we're doing instead is we're going to say, okay, well, just like, hey, window, you really shouldn't be concerned about what's going on with the pressing of keys. Just don't do anything. Just don't handle it. We got it. The application's actually going to handle key presses, so you don't really need to do anything. So that's kind of what this is. So we're just going to go here. I'm just going to copy that, and I'm going to put it kind of up near my other Objective-C stuff. So I believe, yeah, so over by this Handmade window delegate here, right? And I'm just going to call this a key ignoring window because we don't really need this Handmade thing. All right, so we got this key ignoring window, and again, like, I just also want to reiterate, because people will come at me with questions. This is just being in the spirit of Handmade Hero, which means that a lot of times what you would see is, you would see people moving this out to another file. So this would actually, just these two lines would go into an H file, and then this implementation would go into an M file. And that's just kind of a lot of files to be juggling, and really all we're trying to go for is like one kind of quick thing here. So I don't really think there's much of a need to move this out into another file yet. It's a pretty small thing. And another idea that's often employed in Handmade Hero is if we actually just have the platform layer be a single translation unit, the compile actually runs much faster. So that's how we've been able to get these like 5-second compile times. It's just single translation unit. Yeah, it's one big kind of long thing, and a more dogmatic sort of person would, kind of wag their finger at something like this, but like there's really nothing inherently wrong about having one file. If you really think about it, if your program is actually structured in, the right way, right, where the things calling into other things make sense, there just isn't really much of a there isn't much of an argument let's put it this way, there isn't much of a substantive argument to be made that there is really anything wrong with having one file, right? Like other than sort of personal preference or dogma or whatever, right? So we're going to say this is a key ignoring window. So remember, these are subclasses. So this is actually a bit of object-oriented programming. So this thing returns an NS window, but in the allocator, we're actually going to use the key ignoring window. So the actual subclass is the key ignoring window, but we're treating it like it's just a regular NS window. And so what this ought to do is just build that. So now when we run it, we ought to at least have it kind of shutting up. So that's kind of my hope here. Do you hear that? Do you hear the sound of silence? Do you hear nothing? I'm just pressing the button and nothing's happening. So because we subclassed NS window with this key ignoring window behavior, and then we used it in this, we used it when allocating it, that's the actual type now. And so what that means that we have overridden any kind of key press handling that this has by default. So by pressing the key down, any kind of default behavior, we've just overridden that. Empty braces just means it doesn't do anything, so that's kind of what's going on. So we've effectively told the window to shut up, and we said, hey, we've got this, we're handling everything here, and that's kind of what's going on with that. So, kind of to recap, a bit of a long session, but I want to thank everyone for watching that has actually watched all the way through it. What we've done, so we started off not really knowing anything about how to hook into the keyboard. And then what we realized sort of through the process of experimentation was that in order for the operating system to kind of treat this game kind of as an official entity of sorts, we need to be a bundle. And so that means right here in our build, we made a bundle for the application, and then we put this executable inside of that bundle, and we also moved this resource, this info plist, into that bundle. And doing so meant that when we run this application, or rather it means now that when we run this application, the operating system sort of treats it as a more quote-unquote official sort of an entity, which means that this window here can take our key presses, as can the application object itself. That can take our key presses, and in our main run loop, we can then handle these key presses, and we can tie them to a sort of made-up game controller thing that that maps to the keyboard. We call that the keyboard controller, but it's really the same struct that we're using for the PlayStation controller. It's not an exact one-to-one mapping, but the idea is that our logic can treat these the same, and if I want to, over here, instead of using, if I want to switch back to my PlayStation controller, I just change this pointer to the address of the PlayStation controller instead of the address of the keyboard controller. And so this is just a way to kind of very quickly pave the ground and say, okay, we know how to get input from a keyboard, but we're not necessarily, we're not going full Rick Astley here. Like, we're not like making a long-term commitment about exactly how we plan to handle that input. We've just sort of left it open. We know that it works, right? And in the next session, what we'll actually do is we'll hook up the rest of the keyboard. So we'll get the directional keys mapped to the D-pad values. We'll get in the rest of the other buttons. So ASDF. It actually won't take that much time to kind of wrap that up. And then we'll start moving into audio. But that's sort of what we've done today. So again, want to thank you for watching. If you have any questions, please send them my way. Few notes that I sort of forgot to last time because everything was so laggy and I was just even wondering if it was going to work. Thing number one, go and buy the actual Handmade Hero source code. It's only $15. It is arguably one of the best $15 I've ever spent. So you should do it. If you want to support me, I have a Patreon page. So any donations are welcome. Obviously, it kind of motivates me to keep going and doing this and providing you programming content. So that's a big one. And even once the platform layer is done, there's still days like, let's see, I'm on day 37 now. There's still times where it still kind of gets like platform specific. So, the way that the graphics are drawn on the Mac is like slightly different in terms of the individual bits in a bitmap. So I'm gonna continue to kind of make more platform specific stuff so people can still follow along. However, I suspect that if you manage to get to like day 25, it sort of means you're a kind of hardened type of person that is actually able to really push ahead. So I imagine you probably wouldn't need much of my help by that point. But so you can support me, and the code for this is available. I also have the code available for my kind of first pass at a platform layer. That's just me kind of forging ahead. And if you're looking to kind of forge ahead and not really wait for me to finish these videos, I would suggest looking at that, because that really is the full platform layer, following all of the days, all the way, to the point where Casey starts working on the actual game library instead of just kind of focusing on the platform layer. So that's that. And I will wrap up. Go make some bread, make some yogurt, make some games. Talk to you later.